In this video, we will be looking at quadratic equations. We're going to start by looking at what a quadratic function is. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. A can't be equal to 0 because if it was, then we'd have a 0x squared, which doesn't mean anything. We wouldn't have that x squared term. So a can't be 0 because we need to be able to see that x squared term. The domain of a quadratic function is the set of all real numbers. And the first thing that we're going to focus on is writing quadratic equations so that they're set equal to 0. Because when we want to solve a quadratic equation, it first needs to be written in function form, which is where it's set equal to 0. So for this first example, we want to write 3x minus 2 equals x squared as a function. The easy way to do this would be to subtract x squared from both sides of the equation. That would give me a negative x squared plus 3x minus 2 is equal to 0. That's fine, that's technically right, it's a good answer. But we will notice as we go on with this section that more often than not, it's better to have a positive x squared than a negative x squared. So I'm going to take a look at another way to solve this. So if we have our 3x minus 2 is equal to x squared, instead I can subtract 3x from both sides and add 2 to both sides. That way I have 0 is equal to x squared minus 3x plus 2. This equation has the same solutions as the equation we saw before. It's just a lot more user-friendly because our x squared is positive. So keep that in mind as we go along. There are two ways we're going to focus on solving quadratic functions, or finding the zeros, or finding the x-intercepts. There's a lot of names for this. The first way that we're going to look at is factoring. So to solve these equations by factoring, we're going to factor each side completely and then use the zero product principle. The other way we can use is the quadratic formula. So as I said, we're going to start with factoring. First up, we have an x squared minus x minus 6 is equal to 0. So it's a trinomial where our a value is 1. If I multiply my a times my c, I'm going to have 1 times negative 6, which is negative 6. So I need two numbers that multiply to give me a negative 6, but add to give me the negative 1 that is my b value. So that's going to be a positive 2 and a negative 3. So since my a value is 1, I can set up my two sets of parentheses, put my x's in front. I want a positive 2 and a negative 3, so I just factored the left-hand side, and I need to set it equal to 0 because that's what the equation says. What the zero product principle now says is if I have two things multiplied together that equal 0, then one of them must be equal to 0. So I have either x plus 2 is equal to 0, so I can subtract 2 from both sides, giving me x equals a negative 2, or I would have x minus 3 equals 0, where I would add 3 to both sides, giving me x equals 3. Just like we have when we're solving equations in one variable, those linear equations, we can check our answers when we're solving quadratic equations as well by plugging our answer back into the original. We just have to remember that when we're plugging back in, that we have to plug it in parentheses. So we would have a negative 2 squared minus a negative 2 minus 6 equals 0 like we wanted. And then 3 squared minus 3 minus 6 also equals 0. So we know we found our two answers that we're looking for. So we got x equals negative 2 and x equals positive 3. Next up, we're looking at x squared is equal to negative x. On the last slide, we were looking at how, or sorry, 2 slides ago, we were looking at how we need to have our equation equal to 0 before we can start solving them. So I like leaving my x squared positive, so I'm going to add x to both sides. And that will leave me with x squared plus x is equal to 0. Our first step in factoring always is to check for a greatest common factor. Well, between my x squared and positive x, I can factor out an x, and that will leave me with x plus 1 in parentheses. So I have x times x plus 1 is equal to 0. I now have my two things that are multiplied together that equal 0. So either x is equal to 0 or x plus 1 is equal to 0. If I subtract 1 from both sides, I get x is equal to a negative 1. If x equals 0, then I'm going to have 0 equals a negative 0, which is still 0. If I plug in a negative 1, I'm going to have negative 1 squared, which is a positive 1, equals a negative 1, which is also a positive 1. So both of these answers check out as well. Let's try another one. We have 2x times 2x minus 7 equals a negative 12. Again, we need to make sure that we have 0 on one side before we start solving this thing. So I'm going to add 12 to both sides. So that'll leave me with 2x times 2x minus 7 plus 12 is equal to 0. Now I'm going to go ahead and distribute my 2x through the parentheses. That'll give me a 4x squared minus 14x plus 12 is equal to 0. I'm going to check for my greatest common factor. It looks like 2 is going to be the answer. So if I factor out a 2, I'll be left in parentheses with 2x squared minus 7x plus 6 is equal to 0. This is now a trinomial where a is not equal to 1, so I'm going to use the AC method. So we have a 2x squared minus 7x plus 6. If I take my a value times my c value, I'm going to have 2 times 6, which is a positive 12. I need two numbers that multiply to give me a positive 12 but add to give me a negative 7. That's going to be a negative 3 and a negative 4. So I'm going to split my negative 7x term into a negative 3x and a negative 4x. I now need to bring down my first term, that 2x squared, and my constant term, the plus 6. Now that I have 4 terms, I can factor by grouping. So I need to split it into 2 groups of 2. From the first group, I can factor out an x, which leaves me with 2x minus 3. From the second group, I can factor out a negative 2, which leaves me with a 2x minus 3. So that means this factors into 2x minus 3, which is what they have in common, and the x minus 2, which is left over. So going back to the equation I was working with, that 2x squared minus 7x plus 6, I'm going to rewrite in its factored form. So I still have my 2 out front times 2x minus 3 times x minus 2 is equal to 0. So either 2 equals 0, which it doesn't, or 2x minus 3 equals 0. I can add the 3 over, giving me 2x equals 3, and I can divide both sides by 2, giving me x equals 3 halves, or x minus 2 equals 0, and if I add the 2 over, I get x equals 2. So our two solutions will be x equals 3 halves and x equals 2. We are going to take a little peek at one other way to solve quadratic equations that I didn't mention before. We're going to solve using the square root method. The square root method is a method for solving quadratic equations. It's best used if the b value, meaning the coefficient on x, is 0, or if the variable only appears within parentheses raised to the second power. So this one, we don't use it a lot, but it does make certain problems a lot simpler. So if I have p squared minus 18 equals 0, then this is a case where our b value is 0. What I'm going to do is I'm going to add 18 to both sides. So I have p squared is equal to 18. To get the p by itself, I just need to take the square root of both sides. But if you ever take the square root of both sides of an equation, you need to put a plus or minus sign in front of the side that doesn't have the variable. The square root of p squared is just p, and that's going to be plus or minus the square root of 18. We just need to see if we can simplify the square root of 18 at all. I'm going to break 18 down into its prime factors. 18 is 2 times 9, and 9 is 3 times 3. So it looks like I have a pair of 3 factors, and then the 2 doesn't pair up, so it's going to have to stay under the radical. So the square root of 18 can be written as 3 times the square root of 2. So that means our final answer is going to be p is equal to plus or minus 3 times the square root of 2. So we get two solutions, the positive 3 times the square root of 2 and negative 3 times the square root of 2. In the second one, we're looking at x minus 3 quantity squared is equal to 16. This is the case where our variable is in parentheses squared. What's really cool about this is we're so close to the answer, it's crazy. I am going to square root both sides of this equation, and I need to put my plus or minus on the right-hand side. It didn't show up very well, but that's what I'm doing. So if I take the square root of both sides, I'm going to have on the left x minus 3, and it'll be equal to plus or minus the square root of 16 is 4. What I have right now is really two equations. Either x minus 3 equals a positive 4, meaning x equals 7, or I have x minus 3 equals a negative 4 because of the plus or minus sign. And if I add my 3 over, I get x equals negative 1. Those are my two solutions. The third way we have of solving quadratic equations is by using the quadratic formula. The quadratic formula is wonderful because it can solve every single quadratic equation ever. So to solve with the quadratic formula, we first want to make sure that our equation is in standard form. So we have ax squared plus bx plus c is equal to 0. Then we get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And I want to show you a little something, so hold on just a minute.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So now I hope you have that stuck in your head forever. All right, so we're going to work on solving some equations with the quadratic formula. All right, I have two examples here. First up, we have x squared minus 5x minus 9 is equal to 0. So I'm going to identify my A, B, and C values so that I know what I'm using when I get to using the formula. My A value is 1, my B value is a -5, and my C value is a -9. So let's plug stuff in. I have x is equal to -b, so that's -5, plus or minus, let's zoom in a little bit so you can see a little bit better. The square root of my b value is -5, and that's squared, minus 4 times a, which is 1, times c, which is -9, all over 2 times my a value, which is 1. So now we're just going to try to simplify that. The -5 turns into a +5. Then we have plus or minus the square root of, I'm going to use my handy-dandy calculator here. I'm not going to use the square root button yet. I just want to figure out what's under that square root. So I have -5 squared minus 4 times 1 times -9. So I have a 61 under that square root. All over 2 times 1, which is just 2. The square root of 61 doesn't simplify at all, so I'm actually at my final answer. X is equal to 5 plus or minus the square root of 61 all over 2. Now, when you get to My Open Math, you might have to type this in as 2 separate answers. So just be prepared to type your answer in as x equals 5 plus the square root of 61 over 2, comma, 5 minus the square root of 61 over 2. So just don't be surprised if you see that. Next up, we are looking at x squared minus 10x equals 6. We have to make sure we are set equal to 0 first. So I'm going to subtract over my 6, and I will have x squared minus 10x minus 6 is equal to 0. So that means my a value is 1, my b value is a -10, and my c value is a -6. So go ahead and use our quadratic formula. We'll have x is equal to -10 plus or minus the square root of -10 squared minus 4 times our a value of 1 times our c value of -6 all over 2 times 1. I'm going to work on simplifying it. So a -10 turns positive, plus or minus the square root of, this time we have a -10 squared minus 4 times 1 times -6, which gives us 124, all over 2. So we need to see if we can do anything with that square root of 124. So let's go ahead and find the prime factorization to see if that's going to reduce at all. Starting with my 124, I bet it's divisible by 4. It's 4 times 31. 31 is prime, but 4 is 2 times 2. So if I'm looking at the square root of 124, I have a pair of 2's, so I can pull out a 2, and that's going to leave my prime number 31 under the radical. So the square root of 124 can be simplified into 2 times the square root of 31. So I'm going to go ahead and use that here. So we'll have x is equal to 10 plus or minus 2 times the square root of 31 over 2. However, this is a fraction that can be reduced. So I'm going to break it up into terms. So we have 10 over 2 plus or minus 2 times the square root of 31 over 2. 10 over 2 is 5, plus or minus, my 2's cancel, leaving me with the square root of 31. So my final answer is going to be x is equal to 5 plus or minus the square root of 31. We're going to try one more of these quadratic formula problems. It says to find all the zeros, but that just means we're solving. So we have z squared is equal to negative 8z minus 19. I need to have a 0 on one side, and I want my squared term to stay positive, so I'm going to add the 8z over and add the 19 over. That'll leave me with z squared plus 8z plus 19 is equal to 0. Then I can go ahead and use my quadratic formula. Instead of x equals, it's going to be z equals because that's our variable. This time we'll have negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 19 all over 2 times 1. So that gives us z is equal to negative 8 plus or minus the square root of, let's see what that is, 8 squared minus 4 times 1 times 19. That's a negative 12 all over 2. Well, we have to use what we know about complex numbers to help us simplify this. The square root of negative 12 is the same thing as I times the square root of positive 12. So I just need to see if I can simplify the square root of 12. Well, if we find the prime factorization of 12, 12 is 4 times 3, and 4 is 2 times 2. So I have a pair of 2's, and the 3 is going to have to stay underneath. So I still have my I out front. I get a 2 out front as well, but I have a 3 left under the radical. We write all this together as 2i times the square root of 3. So instead of writing the square root of negative 12, I'm going to write it as 2i times the square root of 3. So going back to our original problem, we're going to have z is equal to negative 8 plus or minus 2i times the square root of 3 all over 2. This is going to reduce like the last one, so I'm going to go ahead and break it up. So we have negative 8 over 2 plus or minus 2i times the square root of 3 over 2, which is negative 4 plus or minus I times the square root of 3. So that will be our solution. Z is equal to negative 4 plus or minus I times the square root of 3. So that brings us to the end of the straight math problems. We're now going to go ahead and do some application problems to see how this can be used. The length of a rectangle is 3 inches longer than the width. If the area is 40 square inches, what are the dimensions? Then we also want to know what is the length of the diagonal. So we know we're working with a rectangle. I'm going to draw myself a rectangle. We're going to pretend that that's a really pretty rectangle. We know that the length is 3 inches longer than the width. So if I call that my width, my length will be the width plus 3. We know that the area of my rectangle is 40 square inches, and area is length times width. So if I take my W times my W plus 3, that's my length times my width, that should give me my area of 40. If I distribute the W through, then I'm going to have W squared plus 3W is equal to 40. I can subtract the 40 over. That'll give me W squared plus 3W minus 40 is equal to 0. That looks like something I'm going to be able to factor, because it is. I can factor that into W plus 8 times W minus 5, and that's going to be equal to 0. Now that it's set equal to 0, I can set each factor equal to 0. If W plus 8 is equal to 0, then W is equal to a negative 8. If W minus 5 is equal to 0, then W is equal to a positive 5. But we have to remember that we are now working in an application problem. it doesn't make sense for the width of a rectangle to be -8. That we don't do lengths measured negatively. So our solution is W equals 5. We were being asked for the dimensions. W was representing my width, so our width is going to be 5, and we were measuring in inches. And then the length was 3 longer than that, so our length will be 5 plus 3, which is 8 inches. Finally, they're asking, what is the length of the diagonal? What they mean by that is if we go corner to corner, what is that length? I'm going to call it D for diagonal. Well, that creates a right triangle. And when we have a right triangle, we can use the Pythagorean theorem, the a squared plus b squared equals c squared. So one side's W, which we said is 5. So we'll have 5 squared plus W plus 3, that was my length, that's 8. So plus 8 squared is equal to my diagonal squared. 5 squared is 25. 8 squared is 64. That's equal to D squared. If I add those together, I get 89. So if I take the square root of both sides, I'm going to have my diagonal is equal to the square root of 89. Yes, I should put a plus or minus on that, but our diagonal can't be a negative length either. So we get the positive square root of 89. The problem with that is that doesn't really mean anything. We don't see that as a number. We want to know the length of a diagonal, and the square root of 89 as a length doesn't really click. So let's go ahead and figure out what that is as a decimal. The square root of 89 is equal to about 9.434. Oh, 9.434. So our diagonal is going to be 9.434 inches. There's one more problem we're going to look at in terms of applications. It's going to be a population. The population of a city and thousands of people can be modeled by the function P of t is equal to 0.07 t squared plus 4t plus 110, where t is the number of years since 2000. First up, we want to know what is the population in 2015. Then we want to know when will the population be 200,000. So first up, what is the population in 2015? Well, t represents the number of years since 2000. So if we're looking for the population in 2015, we're going to be plugging in t equals 15. So if I plug that in, we'll have p of 15 is equal to 0.07 times 15 squared plus 4 times 15 plus 110. So 0.07 times 15 squared plus 4 times 15 plus 110 equals 185.75. So does that mean the population was 185 3/4 people? Not quite. The population of a city in thousands of people. So what that means is in 2015, the population was 185.75 thousand. Or we could write it as a standard number as 185,750. Then we want to know when will the population be 200,000. So that means I need to replace the population side, the P, with this 200. Remember that we're measuring population in thousands of people, so I'm not going to plug in 200,000, I'm going to plug in the 200, and that's going to represent how many thousands of people. So we'll have 200 is equal to 0.07 t squared plus 4t plus 110. Or we can solve that, we need to have a 0 on one side, so I'm going to subtract 200 from both sides. That'll give me 0 is equal to 0.07 t squared plus 4t minus 90. Now I could try to factor that, but it does not look pretty. I don't think that's a good idea. So let's go ahead and try the quadratic formula. We'll have t is equal to -4 plus or minus the square root of 4 squared minus 4 times 0.07 times -90 all over 2 times 0.07. So that will be a -4 plus or minus 4 squared minus 4 times 0.07 times -90 is 41.2 all over 2 times 0.07 is 0.14. So we're looking at two answers right now. Either -4 plus the square root of 41.2 divided by 0.14, or -4 minus the square root of 41.2 over 0.14. So let's see what those two give us. -4 plus the square root of 41.2 divided by 0.14 equals 17.28. And -4 minus the square root of 41.2 divided by 0.14 is a -74.42. So remember, we're solving for t here. We had t equals. T represents the number of years since 2000. So our first answer was 17.28. So if we go 17.28 years after 2000, it'll be somewhere in the year 2017. If we go -74.42 years, we're going back in time. We're not going to be focused on going back in time. We're just going to focus on the answer in the future. So it will be somewhere in the year 2017. Now, kind of reflecting back on what we did this section, we solved by factoring. Factoring is nice because generally the numbers aren't too bad. It can be solved relatively easily, and it's just kind of nice to work with. The problem is you can't factor every problem. There are some things that just can't be factored. The square root method is great because things can be solved really quickly, but there are very few instances when we can use it. The quadratic formula is wonderful because it always works. No matter what quadratic equation you have, you can use the quadratic formula. The problem is the numbers get a little bit messy. It's usually longer, but you will get an answer.